this question, it says that n is an integer, and we have to algebraically prove that the sum of 1 over 2 times n plus 1 and 1 over 2 times n plus 1 times n plus 2 is always a square number. So we start with our equation where we add the two. And then what we do is we combine it as a single fraction where we will expand the brackets and then combine the like terms. So as you can see, we've expanded the brackets, and what we have is n squared plus n squared plus 2n plus n plus 2, and this entire thing is going to be divided by 2. So now we combine the like terms. 2n squared plus 4n plus 2 is divided by 2. We know that 2n squared, 4n plus 2 are all divisible by 2. So it becomes n squared plus 2n plus 1. Now remember the rule a squared plus 2ab plus b squared, which is equal to a plus b whole square. So we're going to use the exact same rule over here to prove that it is always a square number. So we know n squared is a squared, 2n is 2 times n times 1, which is our 2ab, and 1 is b squared, which means n squared plus 2n plus 1 is going to be the same as n plus 1 whole square. And that is your answer.